Here's what we're going to start with. I'm going to tell you that these two triangles are similar. And what this means is two things. There are two things this means. One thing it means is that the angle that has the vertex A, the angle that has the vertex B, and the angle that has the vertex C is congruent, each of them respectively, to the angle with the vertex X, Y, and Z. And I'm going to fill in so that we know what we're doing. BAC, ABC, ACB. Those three angles are congruent. And that means that when you look at this right here, you know the angle at the vertex B is congruent to the angle at the vertex Y. The angle at the vertex C is congruent to the angle at the vertex Z. That's the first thing you know. If I have two shapes, let's call this one A, B, C, D, E, F, G, H, I, J, K, L. Okay. If I tell you that this is 30 degrees, this is 50 degrees, this is 120 degrees, and I tell you that shape A, B, C, D, E, F is similar to G, H, I, J, K, L. Do we know what angle L is? Okay. Do we know what angle J is? Up here? This one? 120? Let's go back. Angle A, angle G. They're congruent. I don't know what those are, so it doesn't really matter. Angle B and angle H, they're congruent. 120, where's angle H? Oh, it's here. Angle C and angle I, those are the congruent ones. You see what I'm talking about? It's easy to get confused because you think, well, upper right-hand corner, 120, upper right-hand corner, 120. That's not how it works. The information about what's corresponding to what is contained in the similarity statement, D and J. Now, I know that D is 50 degrees, so that means J is 50 degrees. Hi, thank you. Okay. E and K. All right, let's see. E, I don't know E, so I don't know K. And F and L. Here's L, where's F? There's F, 30 degrees. Yeah, you were right about that one. But it's not because they were in the same position, left side. It's because they're in the same position here in this similarity statement. That's what we're talking about. That's huge. That makes all the difference in the world. And it goes both ways. If you're trying to figure out from one to another how to transfer measurements, which is part of the standard, well, you better understand this. But also, if you get through this entire process and you're showing me that triangle, right, this triangle and this triangle are similar, you have to know A, B, C, D, E, F. You have to be able to write correctly the similarity statement. Which is it? DEF, FED, EDF? I don't know. I don't have any information here. But it makes a difference. And if you get it wrong, then your proof is wrong. Okay. Now, if I don't know what angle it is, then I can tell from sides. But we're going to get to that next. That's the second piece of information you know when you find out that two triangles are similar. First thing you know about the angles, but the second thing you know is about the sides. Now there are three sides to triangle ABC. There's AB, there's BC, and there's AC. Those are the three sides to that triangle. And there are three sides to this triangle: XY, YZ, and XZ. Now you'll notice AB is the first two letters, XY is the first two letters. That's why I put them right next to each other like this, because I'm going to make a ratio out of them. When you write AB without the little hat, that means you're talking about the distance from A to B. This is a number. This is a number. Here's something critically important that most of the students I've worked with get wrong. Oh, look, AB, these two triangles, they're similar. Where are we here? All right, we're looking at these two triangles. Oh, look, this side corresponds to this side. So I guess BC is congruent to FE. Well, they're not congruent. They're not congruent at all. That's not what congruent means. Even if this says 7 and this says 14, I got people writing this. Don't do that. That's right away, your proof is wrong. Why is it significant that BC and FE go together? Well, it's because 14 over 7, this over this, FE over BC, right, is equal to that. And if it turns out that DF and AC are the ones that go together, it's not that DC is going to be congruent to, or the DF is going to be congruent to AC. That's just not right. But what it does mean is that DF and AC are going to make a ratio with the same number. They're a proportion. They're equal. This is what you have to write. Okay? Because this is what you know. Now, that's a lot to learn. I don't mean a lot to memorize, but I mean, if you learn about a triangle that it's similar to another triangle, you suddenly have a lot of information. But the question is, how much of this information do I really need to have before I can stop and say, you know what? I know these triangles are similar. Well, here's the first thing. If you just are looking at the sides and you don't know anything about the angles, if you know all 6 side lengths, you've got triangle 1 and triangle 2, and you know all 6 of their sides, what does that mean? That means that's going to be one that's small, one that's medium, one that's large. Right? So small, medium, and large for number 1. These are the side lengths that I know for the first triangle. And then small, medium, and large for the second triangle. Small, medium, and large. If I know all 6 of them, and I can make ratios out of them that are equal, like that, that's enough to say that the triangles are similar because of side, side, side similarity. This is what I have to do to know for myself that these two triangles are similar. But what do I have to put in the proof? Well, in order to make that proof, I have to make the statement that side 1 is equal to this, side 2, or the small one on the second one, is equal to this, right? The side 3 is equal to this, side 4 is equal to this, and of course for each one of these you wouldn't be putting S1, S2, you'd be putting AB or XY or GH or TV, whatever it is that the side is, but you have to list all 6 measurements. And if you have that at the very beginning, that's what's given. And you have to write that down. Then the second thing you have to write down is the proportion that you find, the ratios that are equal to each other. And you can write them down with the letters, or you can write them down with the numbers. You just have to write them in such a way that I can see you know what you're talking about. Right? So here it might be S1 over S2 is equal to M1 over M2 is equal to L1 over L2. What answer, what reason, what possible explanation can you give for that? Really easy. They're just proportions. And then the third thing is to write the similarity statement. And to write it in such a way that small, medium, large are represented correctly in the order that you put the letters. And what do you say is your reason for that? You say SSS, and you're done. This is actually just a 3-step proof. What I would like to do is have you do this proof for me. Now I'll tell you right now, those two triangles are similar, and what I would like you to do is write the proof of using what I just showed you, and write the similarity statement that demonstrates it. Okay, so this is what I'm talking about. Right? Yeah.
I'm just confused so the given like all that's like S1, like S2.
Yeah.
Okay.
The 6 sides are your 6 pieces of given information, and you need to list them. And if you list them carefully, so that you've listed them with the first triangle, small, medium, large, and then the second triangle, small, medium, large, then you've set it up so that you can check to see, are these ratios the same? 10 divided by 35. That's actually reduces to 2 over 7. 14 divided by 49, that actually reduces to 2 over 7. 18 over 63, that actually reduces to 2 over 7. Now, if you don't notice what it reduces to, doesn't really matter. You could take a calculator, right, and say 10 divided by 35 equals that, and then say, well, okay, that's nice. 14 divided by 49 equals the exact same thing. And then 18 divided by 63 equals the exact same thing. Okay? Now, even if they're close, right? Even if the only difference between them happened all the way in the last column here, then they're not similar. But if they are exactly the same, those are similar triangles. Yes, ma'am?
For the triangles, why is it FED, not EFD?
Well, let's see. Maybe I got it wrong. I did A, B, C to start with. That would be from A, I'm going from small to medium to large, right?
Yeah.
And if I go F, D, E, D, it's small.
That'll be large.
You're right. There you go. So what would it be?
EFD.
EFD. Okay? EFD, small, medium, large. There you go. All right. Let's talk about another way of figuring out whether or not two triangles are similar. if you have, first of all, if I know two of the angle pairs, right? If I know two angles of this triangle, I know the third one, right? Triangle angle sum theorem, right? Just they got to add up to 180 degrees. And if I know two sides of this one, or two angles of this one, I can get the third angle, triangle angle sum theorem. So basically, if I can show that there are two pairs of angles, two pairs of corresponding angles that are congruent, then I know that all three of them are congruent. And remember, the informal definition of similarity is that the triangles are the same shape, but a different size. Okay? So those are similar triangles, and that means that the angles are all the same. So if I can show that there are two angles that are corresponding angles that are congruent to each other, let's say this one, and then maybe this one and this one, well, then I know the third one has to be congruent too, because they all have to add up to 180 anyway. So if I can find one angle of one triangle that's equal to an angle of the other triangle, and then I can find an angle of another angle pair that are equal, right? So this is triangle 1, this is triangle 2, I got one angle, I got two angles. That's enough to make angle similarity. Now, here, this is sort of just handed right to you because it's given in the drawing that this angle is congruent to this angle and this angle is congruent to this angle, and you're not always going to get that. What you got to remember is there are ways you can tell if angles are congruent. For example, vertical angles are always congruent. Vertical angles are the ones that are across from each other at the same intersection if you have two lines crossing each other. Okay. If you have two lines and a transversal that crosses them, if the two lines are parallel, then you know that the corresponding angles are congruent. If the two lines are parallel, you know that the alternate interior angles are congruent. These are things you know. Okay? And you can use that. But you have to say it, and first you have to tell me how you know that the lines are parallel. Now in this case, they're parallel because it says so. It's given. Okay. So let's give you an example to work with, all right? Are those two triangles similar? Just by looking at them, can you tell? Is there enough information there?
No.
Why not?
Because you have no angles. So,
You have no angles at all?
like no given angles.
No given angles, okay? You're right, there's nothing given. But,
We can say
what can we say?
angle ABC is congruent to angle ACB is congruent to angle ECB because vertical angles are congruent.
Vertical angles are always congruent. So, right? There's nothing written there that says that those two angles are congruent, but we know they are because we know that they're vertical angles. Are there any other angles there that we can say are congruent?
Why did you go ECB instead of BCB?
Because I wanted ACB, which is this one right here, and ECD, which is this one right here. These are the two I wanted to talk about. I could have called it DCE, but I didn't.
So it can be called DCE.
Right, with the angles, it doesn't matter what order you put them in.
Aren't you done with the standard? Because there's nothing else that we can check.
Well, if there's nothing else we can say, then we have one pair of congruent angles, and that's not enough to show that the two triangles are similar, right? But what if I did this? What does that mean?
That the two triangles are parallel to each other.
Well, not the triangles, but these line segments, right? Right? So we have to put that in there that we see that. Because now suddenly we have some information that's given. AB is parallel to DE, and that's given. And if it's given, we gotta list it if we're going to use it. Now, why does that make a difference? Finish this up for me.
Okay. Triangle ACB is similar.
Wait, you got to give me one more piece of information, right?
Oh, another one? Alternate interior angle.
Okay. So that would be like the one that's over here.
Yeah.
Okay, so that's ABC, right?
Yeah.
Okay.
Oh, okay.
So angle ABC is congruent to,
DC.
right, triangle EDC. And why is that?
Alternate interior angle is always congruent.
They're not always congruent. When are they congruent? They weren't
They're parallel.
right. They weren't congruent until I put these little things in there, right?
Yeah.
If the lines are parallel. Now, what do I know? Triangle ACB is similar to triangle.
No. Yeah.
Okay. Now, keep in mind, ACB, that means we're going from the one that we didn't do to the vertical angle to the alternate interior angle that we did do, right? So down here, we got to do the same thing. From the angle we didn't do to the vertical angle to the alternate interior angle that we did do. Okay? So we now know those two triangles are similar, and how do we know that? Angle, angle. Okay? Going back to this, we now have two different ways to prove the two triangles are similar. One of them is if we know all 6 sides and we can set up the proportions. The other is if we can use anything at all to show that two pairs of corresponding angles are congruent. There's a third way. Okay. And the third way has to do with finding one angle, one pair of angles that are congruent, right? A moment ago, we had one pair of angles, but that was all we had, so it wasn't enough. One pair of angles that are congruent, and the 4 sides that make those angles create equal ratios. I'm going to show you exactly what that means. Okay? If you have that, that's called side, angle, side. Okay? So let's go back for a moment to the example that I had for you here, where this was A, B, C, D, and E. Right? And the very first thing I asked you is, are these similar? And you said no. You said no because there wasn't anything that was given. And I said, really? Nothing given at all? And you said, well, there's nothing given, but I can say, here's the statement, here's the reason. I can say that angle ACB is congruent to angle DCE because vertical angles are always congruent. Okay? Vertical angles are always congruent. Now, in order to make these similar triangles a few minutes ago, what I did was I made these two lines parallel. Well, I could do something else. What if I put a 7 here and a 15 over here, and then over here I put 21, and over here I put a 45. Well, now I have more given information, don't I? So I got to write that down.
So, Dirk, don't you think ECD is vertical angles to ACB?
ACB and DCE. Yeah, with angles it doesn't matter whether I go this way or this way.
Oh,
Okay? But now I got to write this down, right? So I got these two triangles here. I've got two sides. One is the larger side than the other, right? So CB is equal to 15. CA is equal to 7. Let's do the same thing over here. The larger one is EC is equal to 45, and DC is equal to 21. And that's given. But I didn't just write it down in any random order. I wrote it down with the large one first, the small one second. On the first line, I wrote the one triangle, and on the second line, I wrote the other triangle. Why did I do that? Because I want to know if I take C over CB and put it over EC, is that going to be the same as CA over DC? And if so, what's that ratio going to be? Well, 15 over 45 reduces to 1 over 3, okay? And 7 over 21, 1 over 3 again? Love it. What is that? Proportions. What do I now know? I know that this side and this side form a proportion that's equal to this side and this side. Now notice I said they form a proportion. You do not want to write this because it's just not true. AC is not congruent to DC. They're different sizes. But the proportions they create, those are the same. And what this says is that if I look at triangle ACB, it's similar to the other triangle that has C, right? The angle C is the congruent one, so we're putting that in the same place in the middle. But now, AC corresponds to what side? Uh-huh. And CB corresponds to what side? So that's how I have to write the similarity statement. Side, angle, side, similarity. Right. At the moment, this is what my resource page looks like for this topic. And I got all this extra space here. Okay. Yeah. Oh. What do I do with it? It's a good idea. Good question. Well, you got to ask yourself, what would be the best use for you? Okay? As far as I'm concerned, I would think this is pretty much everything you need to know, and it fits there. So an example or two could go in here.